Hi class, today we're looking at Chapter 1, Lesson 5, Problem-Solving Strategies. Our essential question is how to select appropriate problem-solving strategies to solve non-routine problems. Now, every problem that we've solved so far this year requires us to follow a step-by-step process. Some problems are just looking for how to solve it in different ways. So the first one is looking for patterns. When looking for a pattern, to use this strategy, you analyze the first few numbers in a pattern and identify a rule that is used to go from one number to the next. So again, when you're looking for a pattern, you're just looking whether or not you're adding or multiplying a number in the next step or the next part of the problem. The second one is guess, check, and revise. To solve other problems to solve types of problems, make a reasonable guess and then check it in the problem. You can continue to use the results to improve your guess until you find a solution. So guess, check, and revise is simply you make an educated guess, a reasonable guess, and you check your answer. And if it makes sense, then you can continue. If it does not, it's incorrect, then you need to go back and revise to make sure you get the correct solution. Then the next one is making a table. A table allows you to organize the information in an understandable way. So make sure when making a data table, you are structuring your numbers in a sequence that almost looks like a pattern, and it just keeps everything structured and organized. For example, a change machine takes $1, $5, $10, and $20 bills and dispenses quarters. Jeremy put some bills in the machine and he received 84 quarters. How many combinations of bills are possible for 84 quarters? So if the machine is set up for $20, $10, $5, and $1, then we know that we can break it down. If he is receiving 84 quarters, this means that it's 25 cents for 84, and that would come out to be $21 because 84 times the 25 cents. And that would give us the $21. So now in this case, you can give him one $20 bill and one $1 bill, and that would equal the $21. And so on. So you can give him two $10 bills, and which equals 20, and then one $1 bill, which would be the 21, and so on. So make sure when you're creating a data table, it's going in a specific order and it's very structured and organized. This is one method that we could use to come up with a strategy of seeing how he could be given a certain amount of money if he had 84 quarters. Now turn your notes over to the back side. Now for example number 1, we have Melanie is training for an upcoming marathon. In week 1, Melanie runs 3 miles. In week 2, she runs 3.5 miles. In week 3, she runs 4 miles. Each week she increases the number of miles she ran or runs by 0.5 miles. During which week will Melanie's running distance be 6 miles? So one way to solve this problem is to make a table of values starting with the given data and extending the values until the distance of 6 miles. So for week 1, we were told she ran 3 miles. For week 2, it was 3.5 because we're going to add 0.5 each time. So we're adding, and that is our pattern. Then for week 3, she's running 4 miles. Week 4, it's 4.5, 4.5. Then for week 5, she's going to run 5 miles. For week 6, she runs 5.5, 5.5. And finally at week 7, she runs the 6 miles. So we can create a data table showing the pattern of adding 0.5. So we actually have two strategies going on at the same time. So in the end, it took her 7 weeks to run her 6 miles. Now go ahead and take a few minutes to practice questions 1 and 2. Choose a strategy to solve each problem and justify your answer. So you have to explain how you got your answer, and you also need to come up with a final solution. So there is a final answer for each one of these questions, but you must choose a strategy of how you figured it out. Now, in example 2, we have a bake sale. Brownies were sold for 75 cents each, and cookies were sold for 50 cents each. There are 10 more cookies than brownies sold, and the total amount earned was $40. Now, since we know the total amount they made was $40, we need to figure out how many brownies were sold and then how many cookies were sold at the bake sale. We could use different strategies to solve, so we could use a guess and check method, or we could use a working backwards method. Either way, we should end up with about the same solution. So if I were to do like a guess and check method, I can take the 75 cents for the brownies and multiply by the amount of brownies that I think were sold. So say, for example, there were 20 brownies sold. And then for the cookies, because there are 10 more, so I could say there's about 30, because 10 more than brownies. So that means I would take the 50 cents and add the 20 that I thought for brownies plus 10, which is about 30, and see if that would equal about $40. So I have 0.75 times 20, that gets me $15, and then 0.50 times 30, and that gets me also $15, which is 30. So that I'm close. That's $30. I'm $10 off. So what I can do is I can increase the amount. So I can go 75 cents this time, and I can times it by 25 plus 50 cents, and I can times that this time by 35, because again, there are 10 more cookies than brownies. So now for 75 cents times 25, that would be $18.75, plus the 50 cents times 35, and that would be $17.50. So if I add that to my $18.75, that's $36.25. So again, I'm getting a little bit closer. So I'm going to guess a little bit higher. So I'm going to go to 30. So I'm going to go 0.75 times 30 for the brownies, which is $22.50, $22.50. And then I'm going to see if I add 40 to the cookies, see what that gets me. And it looks like it's about $20, but that would take me over the amount. So I know that the number 20 doesn't work, the number 25, and the number 30. But 30 is too big, so I'm going to decrease it again. So what I can do is go back, and since I know 20 doesn't work, I can guess a little bit higher than 25, but lower than 30. So I'm going to guess for 75 cents of the brownies, I can multiply by 28 plus the 50 cents, and that's going to add 10 more, so I'm going to add 38, because again, there are 10 more cookies than brownies. So in this case, when I multiply the 75 cents times 28, that's $21, plus 50 cents times 38, and that's $19. And it turns out that 19 plus 21 equals exactly $40. So I found out my solution. My solution actually ends up being there are 28 brownies and 38 cookies. And this is simply using a guess, check, and revise. So again, you can use other strategies to figure out your answer. You could have worked backwards, which we kind of did too, because we know that the answer was $40. So in the end, these are our final solutions. As long as you prove your strategy correct, then you do understand. Now go ahead and take a couple of minutes and use the strategy to solve each one of these problems. So again, you could use guess, check, and revise. You can look for a pattern. You can create a data table, or you can work backwards. So some strategies work better than others, so make sure you go back and you think about what you could use.